There is TypeScript for Java C# programmers. Java and C# programmers. TypeScript is a popular choice for programmers accustomed to other language with static typing such as Java, C# and Java. TypeScript type system offer many of the same benefits such as better code completion, earlier detection of errors, and cleared communication between parts of your program. While TypeScript provides many familiar features for this development, it's worth slipping back to see how JavaScript and therefore TypeScript differ from traditional OOP languages. Understanding this difference will help you write better JavaScript code and avoid common pitfalls that programmers who go straight from C# and Java to TypeScript may fall into. Co-learning JavaScript. If you are familiar with JavaScript already but are primarily Java or C# programmers, this introductory page can help explain some of the common misconceptions and pitfalls you might be susceptible to. Some of the way that TypeScript model types are quite different from Java or C#, and it's important to keep this in mind when learning TypeScript. If you're Java or C# programmer that is new to JavaScript in general, we recommended learning a little bit of JavaScript without types first to understanding JavaScript runtime behaviors, because TypeScript doesn't change how you code runs. You still have to learn how JavaScript works in order to write code that actually doesn't something. It's important to remember that TypeScript uses the same runtime as JavaScript, so any resources about how to accomplish specific runtime behavior, converting a string to number, displaying an alert, writing a file to disk, etc., will always apply equally well to TypeScript program. Don't limit yourself to TypeScript specific resources. Rethinking the class. C# and Java are where we might call mandatory OOP language. In the language, the class is the basic unit of code organization and also the basic container of all data and behavior at runtime, forcing all functionality and data to be held in class can be a good domain model for some problem, but not every domain need to be represented this way. Free function and data in JavaScript function can live anywhere and data can be passed around freely without being inside a predefined class or struct. This flexibility is extremely powerful. Free function, though not associated with a class, working over data without an implied OOP hierarchy tends to be the preferred model for writing program in JavaScript. Static classes. Additional 13 constructs from C# and Java, such as singletons and static class are unnecessary in TypeScript. OOP in TypeScript. That said, you can still use class if you like. Some problems are well suited to being solved by traditional OOP hierarchy, and TypeScript support for JavaScript classes will make these models even more powerful. TypeScript supports many common patterns such as implementing interface and static methods. We'll cover class later in this guide. Rethinking types. TypeScript understanding of type is actually quite defined from C# or Java's. Let's explore some difference. Nominal refers type systems. Nominal refined type system in C# or Java. Any given value or object has one exact type, either null or primitive or a known class type. We can call method like value.getType round scopes круглые скобки or value.getClass круглые скобки to query the exact type at runtime. The definition of this type will reside in a class somewhere with some name, and we can't use two classes with similar shape in lieu of each other unless there is an explicit inheritance relationship or tomorrowly implemented interface. This aspect described a relieved nominal type system. The types we wrote in the code are present at runtime, and the type related via their declarations or their structures. Types as set in C# or Java. This meaning to think of one-to-one correspondence between runtime types and their compile-time declaration. In TypeScript, it's better to think of a type as a set of values that share something in common, because type are just set. A particular value can belong to many sets at the same time. Once you start thinking of types as set, certain operations become very natural. For example, in C# this occurred to pass around a value that is either a string or int, because there isn't single type that represent this sort of value. In TypeScript this becomes very natural once you realize that every type is just a set. How do you describe values that either belong in the string set or the number set? It simply belongs to the union of both set, string and number. TypeScript provides a number of mechanisms to work with type in a set theoretical way, and you find them more intuitive if you think of types as sets. Raised structural types. In TypeScript, objects are not of a single exact type. For example, if we construct an object that satisfied an interface, we can use that object where that interface is expected even though there was not declarative relationship between the two. Дальше предлагают к рассмотрению код, в котором демонстрируется применение интерфейс. Points. Не, херня, короче, не важно. TypeScript type system is structural, not nominal. We can use object as a point like because it has y and x and y properties that are both number. The relationship between types are determined by the property they contain, not whether they were declared with some particular relationship. TypeScript type system is also not reified, not refined, reified. TypeScript's type system is also not reified. They are not at runtime that will tell us that object is point-like. In fact, the point-like types is not present in any form at runtime. Going back to the idea of type as set, we can think of object as being a member of both the point-like set a value and the named set of value. Consequences of structural typing. OOP programmers are often surprised by two particular aspects of structural typing. Empty types. The first is that the empty types seem to defy expectation. Класс empty. Фигурные скобки. Открыто-закрыто. Пустые фигурные скобки. Function fm. В круглых скобках. arg double dot empty. Круглая скобка закрыта. Фигурная скобка. Внутри фигурных скобок что-то написано. Не важно, что какой-то текст. Вот. TypeScript determine if the call of fn where is valid by seeing if the provided argument is a valid empty. This does so by examining the structure of фигурные скобки. В фигурных скобках написано k.10 and class empty, фигурные скобки пустые. We can see that фигурные скобки k.10 has all of the properties that empty does because empty has no properties. Therefore, this is valid call. This may seem surprising, but it's ultimately a very similar relationship to one enforced in nominal OOP language. A subclass cannot remove a property of its base class because doing so would destroy the natural type relationship between the derived class and this base. Structural type systems simply identify this relationship implicitly by describing subtypes in terms or having properties of compatible types. Identical types. Another frequent source of surprise comes with identical types. Тут говорится о том, что в класс car ты можешь положить drive, круглые скобки, дальше открыть фигурные скобки и положить что-то внутрь. В класс golfer, в класс golfer ты можешь то же самое положить. И здесь не будет ошибки, когда ты воспроизведешь, написав let w.car равно new golfer, круглые скобки. Golfer это, собственно, класс, который шел после car. А что должна быть ошибка тут? Простите. Тут, короче, говорится о том, что вот ты создаешь два класса, класс car и класс golfer. В каждом лежит по drive круглые скобки. Это, наверное, метод. И ты можешь объявить переменную с именем W и объявить, что у этой переменной будет тип car, а car это класс. Потом ты пишешь равно конструктор, применяешь конструктор new и объявляешь golfer методом. Честно говоря, я от дупля не отстреливаю. Почему тут должна быть ошибка, мне непонятно. Мне, честно говоря... Так мне кажется, тут речь о том, что класс golfer не будет пересекаться с методом golfer, положенным в конструктор new. И, честно говоря, мои знания на том уровне, когда я не знаю, в какой программе, в каком языке программирования подобное могло бы вызвать ошибку. Вот такие дела. Again, this isn't an error because the structure of these class are the same. While this may seem like a potential source of confusion in practice, identical class that shouldn't be related are not common. We'll learn more about how class relate to each other in the class chapter. Reflection. OOP programmers are customers to being able to query the type of any value, even a generic one. В C# static void, log type, внутри треугольных скобок T, за ними круглые скобки, дальше фигурные скобки в фигурных скобках, console.writeLine, круглые скобки открываются, type of, круглые скобки открываются, t, круглые скобки закрываются, .name, круглые скобки закрываются, .com, фигурные скобки закрываются. Because TypeScript's type system is fully erased information about v.g. The instantiation of a generic type programmers on is not available at runtime. JavaScript does have some limited primitives like type of and instance of, but remember that the operator are still working on the value as they exist in the type erased output code. For example, type of new car will be object, not car, or car, not car. теж понятно. Or car string, or car як string. Next step. This was a brief overview of the syntax and tools were in everyday TypeScript. From here you can read the full handbook from start to finish. Explore the playground examples. Красавчик. Кончил.